Tomorrow is our Tamkeen physics exam, so I decided to do a quick and small revision for grade 12 advanced students. And here we go with the question 1. Which of the following is measured with the newtons? So we have 4 options. When they mention or when they say newtons, so they mean by that a force. And we know from chapter 1 that force is equal to Q multiplied by E. So of course, option 1 is the correct one. Continue with question 2. In the figure, a small negatively charged object is placed at rest in a uniform electric field. So here we have electric charge submerged in electric field. Which of the following statements describe the motion of the object when it's released? So how the negative charge will behave when it's released? So we already know from chapter 2.5 that the charge will move backward because it's negative. It will move opposite to the direction of the electric field. So because F is equal to QE, according to the previous question, and according also to Mr. Newton, who said that every time you have a force, acceleration exists. So let's read together first statement. The charge will begin to move with a constant acceleration. So acceleration exists because the force already exists. So option 1 is the correct one. We continue with question 3. According to the figure of parallel plate capacitors, if the area of the plate is 0.01 meters square, what is the capacitance? So also from the chapter of the capacitor, chapter 4, we can tell that equation C equal to epsilon 0 multiplied by the area divided by the distance. Distance is given and the area also as well. And epsilon 0 is given in the formula sheet at the beginning. So you replace a simple replacement of the numbers and the answer is 8.85 by 10 to the power of minus 13 farad. We continue with question 4. The figure shows 3 charges placed at 3 points A and B and C. Which of the following statements is correct about the charges? So from that picture you can recognize, you can say that A and C both have the same nature because both receiving the field lines. Okay, but B is somehow stronger because of the big number of the field lines. So you can see, or you can say that QA is equal to QC. QB is stronger, so of course it's not the second and it's not the fourth option. What about the third option, QA minus QC? No, that's wrong because both have the same nature. So option 1 is the correct one. We continue with question 5. This question is from chapter 3, section 3. Which of the following is not an equipotential surface? So here we have 3 surfaces, A, B, and C. And according to that chapter 3, there is a sentence saying that the equipotential lines are spheres centered on the point charge. So the red lines here, the equipotential line, are centered according to the red charge here, if you see. What about the blue one? It's centered on another charge, but see, there is no charge that centered that circle. So C is the answer in this case, because it's not an equipotential surface, but A and B are equipotential surfaces. So we continue with question 6. What is the equivalent capacitance between A and B in this figure? So here we need to remember these 2 equations. When adding the capacitors in case of parallel, we simply add their values. When adding capacitors in series, we simply do the inverse and do the addition. So we need to simplify the circuit because those 2 capacitors in the middle are in parallel, so we can simply add their values. So 10 here in the middle, it becomes 20 and 10 for the last one. Now all of them are in series, so we need to apply that equation. So here we're applying that equation. 1 over C equivalent is equal 1 over 4. And without forgetting to do the reverse of that equation, and the answer is 4 microfarad. Here we continue with question, yes. Okay, so question 7. The circuit below contains a battery and two capacitors with the same capacitance. So here we have a battery with two capacitance. If the switch was closed in A for the period of time, then it was closed to B. So in the first phase, in the first scenario, C2 here is being charged. After some time, we switch to point B, and the charges will be divided between the two capacitors. So imagine we have two tanks filled of water. The first one is full of water and the other one is empty. So when we connect them together, half of the water will move to the other side and both will contain the same amount of water. So Q1 will be equal to Q2. The charges will be divided into two capacitors, which is also, of course, different than 0. Here we continue with question 8. Two parallel plate capacitors with capacitance C1 and C2 are connected in parallel with a battery as shown in the picture. C2 is double C1. C2 equal to C1. And the energy stored in C1 is equal to U. So what's the energy stored in C2? So here we need to remember this equation, the equation that connects U, the energy, with the capacitance C. So when C is doubled, C2 is double C1. So we replace it in the main equation, U2 equal half. Instead of C2, we replace it by double C1 multiplied by V squared. So U2 now, we cancel numerator and denominator. So U2 equal C1 V squared. So it's double. If you compare it to U1, U2 is double the one in U1. So the answer is 2U. We continue. The electric potential of a point that charged 3 kilovolt is 1.2 meter away from this charge. What is the charge amount? So here, we need to remember the equation that connects all these together. The electric potential V equal K, Coulomb's constant, multiplied by Q, the charge, over the distance. So we need to arrange the equation because they ask for the charge. So Q equal R multiplied by V over Q over K. We replace, and the answer is equal, or it's around 0.4 microcoulomb. Here with question 10, if the electric potential energy of a system of two negative points is 9 joule. What is the electric potential energy of the system when the distance between the two charges is tripled? So here in this question we are tripling the distance. That's the equation that we'll base that equation on. So we have positive charge and the energy created by that charge is equal to Q1 multiplied by Q2 over the distance. So if the distance is tripled, what do you think? The distance and the energy are inversely proportional. So if the distance is tripled, the energy will be divided by 2 because they are inversely proportional. So if R is tripled, U will be divided by 3. Here in this case, in this question, U is equal to 9. So 9 divided by 3, the answer is 3 joule. We continue with question 11. Which of the following statements is correct? So we refer back to chapter 3 section 1 for that question. So from that section you remember this relationship, delta U, the change in the electric potential energy, is equal negative of the work. So here they mention positive, they say positive, and here also they say positive, so we get rid of option B and C, they are wrong. And also in this chapter we always consider the conservative force. we never talk about unconservative force. So of course, option D is also out of the game. So option A is the correct answer. With question 12, we also referred to this question to chapter 4, section 2. According to the figure, a parallel plate capacitor in a vacuum consisting of two conducting plates, each having an area A and opposite charges, separated by a distance d. If the electric potential difference between the two plates of the capacitor is 20 volt, what is the electric potential difference between the two plates when the distance between them is 0.5 d, or half of the distance? So to solve this question, you need to remember this equation from chapter 4, section 2. Delta V equal ED. So what about the potential difference and D? They are directly proportional. If one is cut in half, if one is divided in two, so that will be for the other side. So if D is divided by 2, then delta V is also divided by 2. Here in this case, delta V is equal to 12 volt. So 12 divided by 2, the answer is 10 volt. Here we continue with question 13. Suppose that the voltage at a point is given by this equation. V, that's the voltage, equal to 8x minus 9y plus 5z squared. So what's the dimensions? Determine the magnitude of the electric field. So what equation that connects the electric field and the voltage? Yeah, so E is equal to minus the derivative of each of the dimensions. So Ex equal minus dV over dx, Ey is equal minus dV over dy, and Ez equal minus dV over dz. So when doing the derivative from the first part, we get 8, which is a constant. The same for the y dimension, we get 9. But look what's going on in the third dimension, Ez. When doing the derivative, we still have the z dimension. So z still exists in this electric field, and the other two are a constant. Question 14. Which of the following are materials that have zero resistance? So you should know that superconductors have zero resistance, and that's the new technology coming soon. The superconductors have zero resistance, and that's very, very interesting for physicists and engineers. Here with question 15. So refer for this question to chapter 2, section 5. So what does x represent in the equation? dq equal x, the unknown, multiplied by dv. When you see or when you read dv, so you should always remember the volume. Volume means meter cube. So that's the correct answer. So let's do it the other way also. So that's the quick way because of the volume. So we can tell that it's meter cube, because meter square is about the area and meter is about the distance. So let's solve it the other way. According to chapter 2, section 5, dq equal to lambda dx. Here on the other side, it's equal to sigma dA, because it's two dimension, and the third dimension is equal to rho dV. dV is similar to one that we have here. So of course, we mean by x the rho, which is here the volume charge density. We continue with question 16. For this question, we're still on the same chapter, chapter 2, section 7, to solve this question. So according to the figure, a uniform electric field E equal 360 Newton per Coulomb. That's perpendicular to the plane of one of the faces in the cube, as you see here. If the electric flux passing through the left shaded face is equal to minus 1.2 Newton meter square per Coulomb. So that's the flux. What is the cube side length? So we need to find out the side or the length of the side of the cube. So that's the given. Flux is equal to 1.8 or minus 1.8. Electric field is equal to 360. But to calculate the side of the cube, we of course need to calculate first the area of the square or of the face of the cube. So we need to refer to this equation. The flux equal the electric field multiplied by the area. So we need to arrange the equation. So the area is equal to the flux over E. So it's 1.2 over 360. And the area is equal to 3.3 by 10 to the power of minus 3 meters square. So to calculate the side, it's simple because the side of the square is equal to the square root of the area. Because side multiplied by side give us the area. So side equal to the square root of the area, and the answer is equal to 0.058 meter. We continue with question 17. Assuming that the cube shown in the figure shows 7 electrons. So number of electrons is 7. We have 80 neutrons and a number of protons that we need to define. So if the electric flux is 3.62 by 10 minus 8 Newton meter square per coulomb. So what's the number of the proton? Yeah, what do you think? So of course, that's the flux. We need to use that equation that combines the charge and the flux. Flux equal to the charge Q over epsilon 0. So the charge will be equal to the flux multiplied by epsilon 0, and the answer is 3.2 by 10 power of minus 19 coulomb. But still we didn't finish because we need to find out the number of proton. So from chapter 1, you know this equation that charge, the Q equal E, the elementary charge E, which is 1.602 by 10 to the power of minus 19, multiplied by number of proton minus number of electron. So the only unknown here in this equation, blue equation, is the number of proton. So you arrange the equation and you will get 9 for number of protons. We continue with question 18. Here we refer to chapter 2, section 9 this time to solve this question. So the magnitude of the electric field due to the infinite flat, thin, and non-conducting plane of charge is 3 by 10 to the power of 3 Newton per coulomb. So assuming that the charge is uniformly distributed, what is the charge density? Charge, we need to find the charge density. Okay, so let's start. Charge density, refer to it as sigma. Here it is. So because the plate here is non-conducting, so we need to use this equation. If it was conducting, we use another equation. We get rid of the 2 if it was conducting. But here it's non-conducting, so it's sigma over 2 epsilon 0. So we continue. That's the given. The only unknown here is sigma. So sigma is equal to electric field E, which is given, multiplied by 2 epsilon 0, also given in the equation sheet at the beginning. And the answer is equal 5.31 by 10 to the power of minus 8 coulomb per meter square. So we continue with question 19. A piece of metal with a charge of minus 6.4 coulomb contains that number of proton, 2 by 10 to the power of 20. So what is the number of electron in this piece? So as the previous question, we need to refer to this equation, black equation. Q equal elementary charge E multiplied by NP minus NE. So Q is given, it's minus 6.4. Elementary charge is known, and number of P or protons is also given. So the only unknown is NE. So simple arrangement of the equation, and the answer is 2.4 by 10 to the power of 20 electron. And the answer C is the correct one. So we are approaching the end. Here we are, question 20. The figure shows a blue ball with initially has a charge of 6.4 by 10 minus 8 coulomb. Touch a neutral red ball. What do you mean by neutral? Neutral means the charge is equal to 0. So here we have a blue and red ball. So they touch each other. So what will happen to the charge in this case? The charge will be distributed. Okay, So in this question, they're asking what's the charge of the blue ball after they touch each other. So that's the unknown here. So because of the principle of conservation of charges, the charges before is equal to the charge after. So that's what we mean by charge is conserved. So what do we have in the first place? 6.4 by 10 power of minus 8 plus 0 for the red is equal Q, that after they touch each other, that's the only unknown here, plus the charge of the red ball. So it's 2.6 by 10 minus 8. So you subtract the values and the answer is 3.8 by 10 minus 8 coulomb. Here with question 21. The space between plates on an isolated parallel plate of capacitor is filled with a dielectric material. We have a dielectric material. The magnitude of the charge on each plate is constant. So if the electric field is removed, we take out the electric field. We remove the dielectric. So what will happen to the electric field itself inside the capacitor? So that's in a normal capacitor. We have positive and negative plates, and the black lines represent the electric field lines. They are too many. But if we put a dielectric material, of course, the electric field lines will be weaker, will be less. So if we are removing the dielectric material, of course, E will increase, the electric field will increase. We continue with question 22. A proton is accelerated from rest closed to the positive plate to deliver a negative plate in 0.02 second. If the electric potential difference between these two parallel plates is 100 volt, what is the acceleration of the proton? So we need to calculate the acceleration of the proton. Let's we refer back for this question to chapter 1, I think, section 3. So we know it's a proton, the time is given 0.02 second, and the delta V is equal to 100 volt. And we need to know the acceleration. However, the mass of the proton is given in the first sheet, in the formula sheet. It's 1.67 by 10 to the power of minus 27 kilogram. So to calculate the velocity, there is an equation in the book that said that velocity is equal to the square root of 2q multiplied by delta V over the mass. So q is given, or it's known because it's a proton. So we replace q by 1.602 by 10 power of minus 19. Delta V here as 100 volt and the mass of the proton by that value. So that's the velocity that you will get. But still we didn't finish yet. There is another equation that relates the velocity and acceleration. A is equal to the velocity divided by the time. So we divide that value by 0.02 and the answer is 7 by 10 to the power of 6 meter per second square. Here we are at question 23. The figure shows two identical positively charged balls hanging from the ceiling by insulated massless ropes of equal lengths. So we have two charges have the same mass suspended from the ceiling. What's the charge on each ball? So we need to calculate Q. So for that question, we need also to remember an equation from I think also from chapter 1. They mentioned that tangent, the tan of the angle, is equal kq squared over 2l sine the angles all squared multiplied by mass multiplied by the gravity. So you arrange the equation, and q now is equal to the square root of that amount. But keep noticed, or you should know, that the angle here in this case is half of 40 degree. So it's 20. So here in this question, you need to consider the angle as 20 degree. And the charge that you'll get at the end when applying these numbers on the calculator is 9.6 by 10 power of minus 6 coulomb or microcoulomb. and answer A is the correct one. So that's it for now. Thanks for watching and see you on the next exam, and wish you a full mark tomorrow inshallah.